Let's look at other points here. Now, point P, which is on 60 degrees north and 120 degrees east, and point Q is on 30 degrees south and 120 degrees east.
Okay.
So look at the points from a distance always and analyze how these points are. You'll reach a point where you can actually picturize it in your mind without even drawing the figure, right? So how can you define these points in terms of same or different hemisphere or same or different meridian? How can you say that?
In the same meridian but different hemisphere.
That's right.
Like P is in the northern hemisphere and the Q is in southern hemisphere.
That's correct. Different hemisphere and same
But same meridian.
meridian. So very quickly tell me which view is going to help you here.
Because like side view is the side view only.
Side view is not required because the same meridian or anti-meridian quiz. We can draw side view, it's okay. But
side view means basically that front view.
front view, correct. Yes,
Which
side view is also front view, correct. And what about top view?
Yeah. Top view we would be able to do it, but it is like southern hemisphere we won't be able to.
Don't do top view because if you draw top view and draw outer lines and stuff, you get confused. No top view for this because you cannot see the other hemisphere is hidden. So don't draw that, right? It's only the front view here. Let's draw.
Yeah.
Make the diagrams bigger. Make solid diagrams. Take time and draw the diagrams here. So east. You can start drawing. You can draw diagrams. It's fine. South. You have the meridian here, which is 120 degrees east. So from which side are we looking at it? Is it the prime meridian side or anti-prime meridian side? So anything beyond 90 degree east-west, you probably have to go around to kind of see that. So it's more like from the anti-prime meridian side. Yes, but still your east and west is not going to change.
Yeah.
Right? Perfect. Yes. Let's look at the hammer, the parallel of latitude here. One is 60 degrees north and the other is 30 degrees south.
South.
The point of intersection of 60 degrees north with 120 is Papa, and this one is
Point P.
Quebec. Yes, Q.
Point Q.
You are asked to find out the shortest distance again. So shortest distance is nothing but the great circle distance. Shortest arc of the great circle passing through these 2 points. Right? What is the great circle?
That is 120 degree east. Basically.
120 degree
In
east
this case.
meridian is the great circle. So right. So here again you can see that this is 60 degree north because at the center of the earth.
Yeah.
Sorry.
To this point here.
To the point Q, this angle is going to be 60 and therefore this
60 degrees.
arc distance is what is called as the latitude. Now joining Q here, this angle is 30 degrees, it is a smaller
30
angle
degree.
measured towards south, hence it is 30 degrees south, right? And this angle is 30 degrees because of the arc distance. Therefore, in this case, unlike in the previous case where we subtracted, we are looking at a complete, this is the distance required, therefore the corresponding angle we are looking at is the complete angle.
Will be added.
So usually the students, they learn like same hemisphere subtract, different hemisphere add. I don't think that is really necessary. If you can kind of understand where the points are, you will automatically know whether to subtract or add. So we need this distance, therefore the angle corresponding to that has to be the sum of the 2 latitudes, right? So what is that? That is again Chilat.
Chilat.
Chilat here is 60 plus 30.
60 degree plus 30 degree.
which is
90 degrees.
Right? Shillong?
Shillong is 0 only, like
Zero.
on the same meridian, 120 degrees east.
That's right, same meridian, right? Alright, now how will you find the shortest distance? What you have is a
The
degree.
shortest distance will be Yeah, I have the degree, so I'll convert that into the arc distance. So firstly, I'll do 90 degrees multiplied by 60. So that will give me 5,400 minutes. Now here I'll do that check, 5,400 minutes.
Correct.
I know that 1 minute is equals to 1 nautical mile.
Okay.
Therefore, 5,400 minutes will be 5,400 nautical miles of distance.
Distance. So we have, you know that we are traveling on a great circle, which is 120 degrees east meridian, and therefore I can do this conversion, right? All right. Let's look at point M, which is say 27 degrees north and 10 degrees 45 minutes east. N, which is on 27 degrees north, 62 degrees 55 minutes west.
So this is 27 degree north.
Understand how the points are here? So same hemisphere,
Yeah.
it is like same hemisphere, and therefore same or also same parallel of latitude,
Yeah.
different longitudes.
Okay, sir, the diagram I have drawn.
Yeah. So you can talk me through
We'll be
and
plotting,
yeah, 27 degrees, right?
we'll be plotting at 27 degree north of our latitude.
Mm-hmm.
We'll be taking one meridian like that. Meridian will be 10 degree 45 minutes of east.
Yeah, since you have two meridians here, two different meridians, what you told me earlier makes sense here. We have to probably mark the prime meridian to make it more clear.
Yeah.
Not necessary, but initially probably you can do that. So if I mark the center portion as prime meridian here. So first thing first, I've started with the front view. If I want, I can use a top view also. Given it's confined to a particular hemisphere, I can still draw top view. We'll see that. But yes, this is the prime meridian. 0 degree east west. Yeah. Where are you going to draw what?
So from prime meridian it is fine. So like so to the right of the prime meridian, I'll be drawing a meridian of 10 degrees.
Yeah.
Yeah, to the east of it, I'll be drawing 10 degrees and 45 minutes of my latitude.
Longitude.
Yeah. To the west side of my prime meridian, I'll be drawing 62 degrees and 55 minutes of latitude west.
Longitude.
Yeah.
It's longitude, not latitude.
Sorry.
Yeah.
Longitude, yeah, sorry. Longitude.
Yes.
Sorry.
Alright, now let's mark the points.
So the points will be point towards the eastern side will be point M.
Okay.
And that other point will be N.
Yeah.
So we need to calculate the distance between M and N.
That's right.
But the only thing is that it is not a great circle.
Yeah. Yes. So that's the catch here. So basically, it's not the great circle, right? So basically, which means you can find out everything what you want, but you cannot do the conversion directly. So let's find out the stuff, the changing things here. So unlike the previous question, you can see there is no change in latitude here. So here the change in latitude is what? 0.
Latitude is 0.
27 degrees north. What about Geelong?
Long since we are in the different hemispheres. One is the eastern and one is the western. So we'll add up the values.
So center of the earth.
So
we join to the prime meridian, and this is going to be how much? 62 degrees.
62 degrees and 55 minutes
Right.
west.
If I join it to this one here, this is going to be 10 degrees 45 minutes towards the east. Right? Therefore, we are looking at change in longitude between these two meridians here, which means it has to be a distance Which has to be a change in meridian. It's measured along what? It's always measured along the equator.
Along equator.
So what is that going to be? It's going to be a sum of these two, which is going to be the total Chilong.
Yeah.
So Chilong is going to be
Yeah.
62 degrees.
73 degree.
So you have to add, right?
55 minutes plus 10 degrees 45 minutes.
So I hope you know how to do
So
this
that is
using your
70.
scientific calculator, your DMS function. Do you know how to do it? Degree minutes.
Yeah.
Then it is fine, right? Do you know how to do it without that?
Yeah.
How do-
Without that, normally, like whenever this 60, suppose 80 is coming, so I'll just put 2 and then 2 I'll carry forward.
Definitely. So it's 5 plus 5, 10. You're getting 100 minutes here, which is,
Yes.
and then over here you'll be getting 2 degrees, 7, and 72
Yeah.
degrees, 100 minutes. And we don't have this 100.
Yeah.
Therefore, we have only 60.
Yeah.
Therefore, what do? We take 60 out of it,
Well, for,
and we make 72, 73. 73 minutes, degrees, and 40 minutes. So what do you got?
50 minutes, 62 degrees, 55 minutes, and 10 degrees in, 45,
Yeah.
40 minutes.
So remember I told you in the first
Minutes.
class that my scientific, my CX3 went off during the exam. So in the event your scientific calculator, because
Yeah.
all electronic devices can go mad. That is why even on the aircraft, in the aircraft we have standby devices, even though we have electronics there, because in the event everything goes off, you still have something to rely on. So similarly, the basic calculation you need to know because it can help you in the event. Or sometimes sometimes doing like this will be quicker than the calculator. By the time you take the calculator, you can simply scribble and find out. So it is 73 degrees 40 minutes. Yes, but the hard part here is you cannot really convert this to minutes. If I convert this to minutes, what's the minute value? How will you convert that? 73
Yeah,
into 60
73 degrees into 60
plus
plus 40 minutes.
40.
4380 plus 40, it is coming 4420 minutes.
Right. Now, as I've always told you,
Total.
take a pause here before you convert. So in this case, 1 nautical mile equal to 1 minute is equal to 1 nautical mile is not possible because you are not measuring it along great circle. If you had measured the same thing along the great circle equator here, it would have been possible, but it is not possible here. Right? So in that case is when we actually use this equation of
Departure.
departure equation. Right? Do you want to find out? Even since you know it.
You can find 4420 multiplied by cos of 27. It is 3938 decimal 2 nautical miles.
So departure in nautical mile is Chilong in minutes times cos of latitude. That's going to be 4420 minutes times cos of 27 degrees.
27 degrees.
So you're going to get a value less than 440 or more than 440?
It will be less.
Be less, right? Because the distance is going to be lesser as we go on. But how much?
Yeah. 3938.
39, and the value is in nautical miles. Departure equation will yield you the value in nautical miles. So I'm making you do this because since you know it, otherwise I probably will stop from here, right? But yes, this is how it is. So you can see how the distance is shorter,
Yeah.
right? Perfect. All right. Now let's look at. You can just copy this down if you haven't. What about top view? So I think you are quite good at this, but somehow students really find it difficult to find the Chilong from the front view because it's towards you, right? So that is when the top view becomes much more easier because top view is proper circle,
Yeah.
and you can kind of navigate through it much more easier than this one. So you can try, if you're confused, you can probably use a top view. I've also told you top view can be also beneficial when we discuss about time because it's extremely useful and easier to understand, right? Yeah. So happy with it?
Yeah, I'm done.
Done.